All right, go and open your textbooks to page 168. We're going to take a look at your homework that you had last night. You had just 3 questions on page 168, numbers 35, 36, 37. Also on page 167, number 2 was a system of equations you were supposed to graph. And then numbers 15 through 24, you got to pick which method you wanted to use, whether the elimination method or the substitution method. Excellent, good. All right, where's the work? I got you, okay. All right, good. All right, and okay. All right, there's those, and then this is number 2 right here. Ah, okay, yeah, you're supposed to graph it. So it looks like you try to use some algebra to solve instead of just straight up graphing using slope-intercept form or intercepts. Quickly, let's take a look at the answers to 35, 36, 37. Number 35, what term describes a linear system that has exactly one solution? Noah.
System of linear equations.
So the term that describes a linear system that has exactly one solution is a system of linear equations? Maddie, help him. Consistent. The lines intersect. What term describes a linear system that has no solution? Noah? Inconsistent, because the lines would be parallel. And what term describes the equations in a linear system that has an infinite number of solutions? Therefore, the answer would be indeterminate. Reckon?
I put the answer indeterminate.
Indeterminate would be the solution there, but the equations are said to be dependent. Dependent equations coincide there by giving an infinite number of solutions. A little bit of a review there. Turn back to page 167. Let's take a look at number 2. We were given the equation 2x negative y equals 8. We were also given the equation x positive 3y equals negative 3. And we were instructed to solve this particular system by the graphing method, which is never first choice. The only time I would ever use the graphing method is if I'm specifically told to use the graphing method. If I'm ever given a choice, this is never something I would choose. But you weren't given the choice. You were told to graph, so you had to do it. That first equation, Brecken, we could either graph using the intercept method or slope-intercept form. Which would you like to use? All right, so let's go ahead and rearrange the equation to get it into that y equals mx plus b format. What would the equation look like when rearranged, Brecken? Great job. Mentally doing a double switch, I assume, right? And so we get the y equals 2x minus 8. So to graph it, I'm going to start by plotting my at. Then we're going to rise, run, and when we connect the dots, we get a line that looks like this. All right, then for the second equation, do we want to go intercepts or slope-intercept form? All right, it's going to take 2 steps to do it. The first step is to move over to get and then to get. Good. And so we're going to plot our y-intercept at. Then we're going to rise, run backward. And when we connect these dots here, we get what point of intersection, Brecken? Good. Appears to be 3, negative 2. How many had that answer for the system? Maddie, question. All right, let's go and take a look at 15 through 24. I'm going to read you the answers. If you got it right, put a little check mark. If you got it wrong, cross it out. We're going to go through any questions we had on wrong answers. But imagine for a moment that this were a 10-question quiz. Curious to see how we would do. Your answers for numbers 15 through 24. Number 15, 1, 2/5. Number 16, 2, 0. Number 17, 1, 1. Number 18, 2, 0. Number 19, 2, negative 1. Number 20, 11/5 or 2 1/5, comma, 2/5. Either 11/5 or 2 1/5, comma, 2/5. Number 21, 5, negative 2. Number 22, 1, 0. Number 23, 2, 1. And number 24, 2, 3. Would there have been any hundreds in this class had this been a 10-question quiz? How about 90s? You only missed 1. 80s only missed 2. Making me a little nervous. 70s, you missed 3, but you still would have passed. Ooh. Noah, how many did you miss? 4. Reckon? 4, okay. Which ones did you miss, Maddie? Noah, which ones?
18, 20, 22, and 23.
All right, same ones as Maddie, but also missed 18. Reckon?
17, 24.
All right, and then a couple of the other ones that were already up here. All right, let's go take a look at these together. Number 17, we got the 4x positive 3y equals 7. We've got a 3x negative y equals 2. Brett, and I think you were the only one who missed this one. Substitution or addition? Where you got the, by rewriting the bottom equation as, and you took the 3x minus 2, you plugged it in for the y. How did you then rewrite the top equation?
4x plus 9x negative 6 equals 7.
You combine the x's to get, and you move the negative 6 over as a positive to get. So you got x equals,
I put 14 instead of 13.
so you got 14/13. That's ugly, man. Yeah, 1 would have been a much easier answer. And then here we plug in the 1, 3 times 1 is 3 minus 2 is 1, so 1, 1. A much easier answer. Good to go now? All right, number 18, Noah, I think you were the one who missed this one. We have a 6x plus 2. Look at that top equation, class. On number 18, 6x plus 2y equals 12. Noah, do you see something we could do to simplify that equation? You didn't have to do it this way, but what could we have done, Noah? What would we have gotten if we took a 2 out of everything in the top equation?
3x positive y equals 6.
And then the bottom equation's already good at x minus y equals 2, and suddenly, Noah, there's something that's already set to drop out to give us,
4x equals 8.
and so x apparently equals, and then you either plug the 2 in here or here. Either way, this gives you a 6, which when you move it over as a negative gives you nothing. Here you have a 2, which you move over to the other side as a negative gives you nothing. So apparently either way, y equals 0, and 2, 0 our answer. Does that make sense? The other option, of course, would have been multiply 2 all the way through the bottom, and that would have made stuff drop out the same way. Or you could have tried to solve by substitution. That would have worked also. Number 22, Maddie, let's come to you on this one. Substitution or addition, Maddie? Substitution on 22. Excuse me, I'm saying number 22. Number 20 is the next one. Let's go with 20. Maddie, substitution or addition? Addition. All right, so you have the 2x minus y equals 4. You have the x positive 2y equals 3. And you multiplied the bottom by 2, and that gave you a new bottom equation of, and of course the top equation is still 2x minus y equals 4. Will the x's drop out? No, I need to, across the top equation is where the smaller numbers are, so I would definitely change across the top. Negative, positive, negative. That allows the x's to drop out, giving me, and right there, it would be so tempting to say 10, which gives you y equals 2, but it's not. It's 2, which gives you a really ugly y value. Yeah. And I don't want to go plugging that back in. Now, honestly, truly, it wouldn't be the end of the world if we were to plug it in right here, right? X plus, Maddie, what is 2 times 2/5? No, 2 times 2/5. 4/5. right, is equal to 3. And then we could subtract 4/5 from 3 to get 2 1/5. I guess you could do that. In general, though, I get a fractional answer. I don't want to mess with it, right? So what's the recommendation if you get a fraction? Start over, but instead of knocking out the x like we did last time, knock out the y. So now multiply that to get, and of course we'll keep for now the x positive 2y equals 3. Very conveniently, the 2 y's, giving us, and again, be careful not to subtract. We're adding, so not 5, which gives us 1, but 11, which gives us a rather ugly x answer. 11/5 or 2 1/5, and there's our 11/5, 2/5 answer. Does that make sense? I believe, Noah, you missed the same problem. Questions on that one? All right. Let's take a look at number 22, and let's come back to Noah on this one. Addition or substitution on 22?
Addition.
Addition, all right. You multiplied the
Top.
by
2.
2. Oop, I just erased the numbers. I think I can remember them. So when you multiply the top by 2, what did it give you?
Negative 6x. Negative 2y equals negative 6.
All right, I would have just gone 6x plus 2y equals 6 initially, and then 5x plus 2y equals 5 initially, and I would have actually changed the signs across the bottom just to avoid negatives. So that way 6x minus 5x is just x. 6 minus 5 is just 1. Now, you would have got negative x equals negative 1, which means x equaled 1 anyway, right? Did you get x equals 1? So your problem was plugging it back in. Go back to the 3x plus y equals 3. Plug the 1 back in for the x. 3 times 1 is. But when you move it over as a, it gives you 0. And there's our answer, 1, 0. Make sense? 23, Maddie, I'm going to come back to you on this one. Surely you solved by the elimination method, correct? You solved substitution?
No.
Addition or elimination? Okay, and you got rid of the y. Good choice by multiplying the and to get and then you plug that back into the top equation. Good. I would avoid the bottom equation. I don't like negatives. I'd rather plug it in here where there's a positive. 2 times 2 is, move that over as a, to get 3y equals, so y equals. Did you find a mistake? All right, just be careful there. And number 24, coming back to Brecken, 5x negative 2y equals 4, 2x positive 3y equals 13. I assume you used the elimination method, and you multiplied the, good, try to knock out the y where the signs are already different. Top equation became?
15x negative 6y equals 12.
Bottom equation.
4x positive 6y equals 26. Cancel out the 6y. 19x 38.
And it does actually divide evenly. 19 goes evenly into 38 how many times? 2 times. Did you get this far?
No, I don't know what I did here.
Comparing your work that you did last night to the work that I have here on the chalkboard?
I got.
All right, what should we have done next? Once we got the x equals 2.
You plug it in for the top.
All right, and when,
So I don't know what I did there. That's even to this bottom.
you subtracted the 26 and 12 instead of adding them. Yep, should have gotten 38, you got a 14 instead. So keep in mind, it would help if you wrote the little addition sign here, so you remember you're adding this. Unless one of these had a negative, you know, well, of course if both of them have negatives, then it's adding two negatives, right? But we are adding, so keep that in mind. Once we get the 2, you said plug it back into the bottom equation. Again, avoid negatives at all costs. 2 times 2, move the 4 over as a negative to get, and a 3y equals 9y equals. And there's the 2, 3 answer we should have gotten. Number 12. Number 12, write it down in your paper. The next positive 3y is equal to 5. We have a 2x. Positive 6y equal to 12. And I'm leaning toward the addition method here, because I see that if I just multiply the top class by 2, I can knock out those x's, right? And so when I multiply the top by 2, what does it become? Noah?
2x plus 6y plus 10.
And of course the bottom equation I'm going to leave for now, 2x plus 6y is equal to 12. But the x's don't cancel unless class I change signs. So let's change signs across the top is where the smaller numbers are. Change them there. My x's are going to cancel. Y's. Oh. So what's left on the left-hand side of the equal sign? If the x's cancel and the y's cancel, what's left?
0.
Nothing. How do we say nothing?
0.
0. Over on the other side, negative 10 and positive 12.
2.
True or false? 0 equals 2. It's called a contradiction, remember? A contradictory equation. Do you know what the answer to a contradictory equation is? No. Solution. Here you have two parallel lines. 2x plus 6y cannot equal 10 and equal 12 at the same time. If you arrive at a position where both variables cancel, but you're left with 0 equal to something other than 0, that's a sign, without graphing, this would have been two parallel lines. This would be an inconsistent system. Questions on how to spot, without graphing, an inconsistent system. Again, with graphing, it's easy. The lines are parallel, no solution. Not graphing it, you arrive at a contradiction. No solution, it's inconsistent. Look at number 14. Look at number 14, we got a negative 3x. Positive y is equal to 5. We have a 6x. Negative 2y, excuse me, is equal to negative 10. By the way, looking at that bottom equation, I could just knock a 2 out of everything, couldn't I? What would my bottom equation look like if I knocked a 2 out of everything? Bracken? Hey, look at that. The x's are already set to cancel, right, class? Negative 3x, positive 3x cancel. What about the y's? Oh, so what's left on the left? 0. And on the right-hand side, whoa, is that a true statement? Yes, that is not a contradiction. When does 0 equal 0, class? Always. However, my answer is not all real numbers here, but all real numbers that lie along one of these lines. Now again, in Algebra 2, I'm going to show you how to handle this set of dependent equations. You realize this really is just the same equation, right? If you were to change all the signs, oh, it's the exact same equation, right? These are dependent equations, so your solution is indeterminate. There are infinite solutions. We describe the solution, therefore, as being indeterminate. Now, again, next year I'll teach you how to handle an indeterminate solution. There's actually an algebraic way to represent it, but for now, we're going to leave it at that. Questions on number 14. All right, questions on what to do with inconsistent systems where the lines would run parallel if we graphed them, and dependent equations where the lines would coincide if we graphed them. Again, we're not graphing. We can still tell it's inconsistent because we need a contradiction. No solution. We can tell the equations are dependent because they're literally the exact same thing. Everything cancels, even on the right. Dependent equations have an indeterminate solution. Any questions on these? On your paper, go and write down this system of equations then. X fourths plus y sixths equals 4. X fourths plus y sixths equals 4. And 3x eighths minus y halves equals -3. Right about now, you should be thinking, oh, Mr. Nadaski, I was just starting to get the hang of systems of equations. And then you do this to me. I hate this. How many thinking I hate this? You should be, all right? We hate fractions and equations. Even when it's a system, we still hate it. And you know what we used to do when we would see fractions and equations? We'd get rid of them. How would we get rid of them, class? There we go. Okay, for a minute I was worried. Multiply everything by the LCD. Now, one word of note. This equation has a particular LCD. This equation has its own LCD. So when we say multiply everything by the LCD, I do not have to find a denominator for everything. For the top equation, it'll have an LCD. The bottom equation will have an LCD. So for the top equation, what is the LCD, class? 12. I'm going to multiply 12 by everything. In the bottom equation, what's the LCD? I can do better than 16. 8. But it's not wrong to do 16, though, right? Just to be clear. So we're going to multiply everything by the 8 in a moment. So let's go ahead and multiply the top by 12. 12 and 4 cancel, class, to give me
3.
So 12 and 6 cancel to give me
2, 1.
so.
2, 1.
And notice here, this is not a denominator. 12 and 4 do not cancel. 12 times 4, class, equals
48.
everything, even the 4. Just because it's not a fraction doesn't mean it doesn't get multiplied by the 12. Make sense? At your seats, multiply the 8 through the lower equation. Maddie, what's the bottom equation going to become? Did we get the same equation Maddie did? Boom, fraction's gone. We're back to normal. So if you see fractions in your system, you don't panic. You may hate it, but you can take care of it quickly and easily. What should we do now, Brecken?
Change this on the bottom. Change it equals, shift y equals
6 times 12 is 72, so we get y equals 12. Now, here's another thought. You know how I always say go back to the original and plug it in? That thing? No. So first of all, you see fractions in your system, clear the fractions out of each equation separately. Once you get your answer, do not go back to the original where the fractions are. Oh no. Go back to maybe this equation, and let's plug the 12 in here, Noah. And it's coincidence here that the two LCDs I chose happen to be the solution, 8, 12. That is actually coincidence. Don't expect that to happen all the time. Happen to be the case here. Do we see how to handle fractions so that we're not panicked by it? We may hate it, but we know how to handle it. Questions? Let me give you another one of these. 2x fifths minus y thirds equals 18 fifths. And x halves plus y sixths equals 1. At your seats, knock out the fractions. And then stop and wait. Just do that first step. Just knock the fractions out. No, a top equation when you multiply by the 15.
6x negative 5y equals 54.
Bottom equation when you multiply by the 6 bracket. Do we get this system? Now what, Maddie? I'm sorry?
Actually, you can multiply by 5.
Good. Bottom by 5 really isn't hard, and it already would knock out easily. So what's the bottom equation become?
15 plus 5 equals 6.
All right, so now as we add these two together, the 5y, negative 5y cancel, giving me equals, so x equals 4. Do I go back to where the fractions are, class, to plug that in? No, I'm lazy and I'm not a sucker for punishment. So I'm going to go back to this little easy equation we had a minute ago, the 3x plus y equals 6. I'm going to plug the 4 in right there. Where anyone, we multiply 3 by 4 to get,
12.
move it over as a negative to get
6, negative 6.
negative 6, and that's y equals negative 6. So there we go. There's my solution for negative 6. Easy enough with fractions. Again, it may be a little annoying, but we know how to handle it. Turn the page. Do number 27. Actually, number 27. This is actually pretty easy. I actually don't even need to knock out the fractions here. Normally I would. What is it about 16 that shows me I don't need to knock out the fractions? Thoughts?
Positive half, negative.
Yeah, look at your y's. Positive, negative, half y already cancel, don't they? Now be careful here. What's a 4th x plus 3/4 x?
X.
Right, 4/4 x, 1x, or just x equals, well, that was easy. Now where it gets dicey is if you haven't knocked out the fractions, plugging in the 9 is going to be a pain. You know what I'm saying? So let's take maybe this equation. Let's go ahead and knock out the fractions now. Multiply everything through, Maddie, by, to get what? And now let's plug the 9 into that. Rather than plugging it in where the fractions were, although yes, it was super easy to get your initial answer, plugging it back in would be a pain. So now we plug that in, move the 9 over as a, to get 2y equals, and so apparently, y equals, oh well, 15 halves it is, 9, 15 halves. Would it have been wrong to multiply the 4 through both of them and knock out the fractions first? Not a problem. You still would have had a relatively easy system knock stuff out, right? You don't lose that by getting rid of the fractions, but you know, just a little thought there. Look at number 30. This is weird. X plus y equals 6. 2x plus 5y equals x positive 7y. Thoughts, Noah?
Get rid of the smaller one.
Yeah, let's not have x's and y's on both sides. In fact, what I really like is what format, Noah? What layout do I like to see in my systems? Good, x, y equals number. And if we look, top equation, x, y equals number. Bottom equation, x, y equals x and y. Let's just move both of them over to the other side. Does that make sense? Let's just ditch both of them. What does the bottom equation look like if I move the x and the 7y to the other side, Brecken? Good, x negative 2y equals 0. And now we're ready to solve. So again, don't let it throw you off when there's more x's and y's than I'm used to seeing. Just get rid of them and move them over, get rid of them, and let's keep rolling here. Where maybe we do what now, Brecken?
On the top, right two.
We could, okay. And top equation becomes 2x plus 2y equals 12. And that allows the y's to cancel, giving us So x apparently is 4. Go back over here, plug in that 4, anyone y is going to equal 2. And there's our solution there. Questions on that? At your seats, do 28. Check your initial step on 28. Good to go? Keep working if you are. If not, questions? What number would we need to knock out the x, class? What would the 9x and 5x both have to become? 45x, right? What if we tried to knock out the y's? What number would 10 and 15 have to become? 30. Which is easier, to get a 45 or to get a 30? I'm leaning toward the 30, right? 3 in the top, 2 in the bottom. Not wrong to multiply by 5 and 9 to get 45. Nothing wrong with that, but I'm lazy. I always look for the easy way. Good to go. Do 29. Once you finish 28, go on to 29. the sake of time, pencils down, look up this way. On number 28, how many got 3/3 for our answer? Excellent. Number 29, I realize some of you didn't get opportunity to finish. I went and brought the x over as a negative, brought the y over as a positive, to get x positive 2y equals 3. Really didn't feel like lining stuff up, so I'm like, you know what, let's just solve by the substitution method. So I sent the 2y over as a negative to get x equals 3, negative 2y. Plug that in here for the x, distributed, y equals 2/11. I normally wouldn't want to plug it in, but that's one of the strengths of the substitution method, so I wanted to show you how that would work. Keep in mind that 2 times 2/11 is 4/11. But you can't take 3/1, 3/1 minus 4/11, so I multiplied top and bottom by 11 to get 33/11 minus 4/11. Do you understand what we did there? Subtract, get 29/11. There's our x value. Of course, y was the 2/11 questions on this. Homework for this evening is to do page 174 at the top. Page 174 at the top, numbers 7 through 16. Page 174 at the top, numbers 7 through 16. We'll take a look at that in our next lesson tomorrow. Have a wonderful rest of your day.